Because of the high color rendition and Kelvin temperature, along with the efficiency of the induction technology, typically you can cut the wattage in half when replacing high pressure sodium. The feedback from the residents in this area has all been positive, as many of them agree that the higher quality of light makes them feel safer at night. Along with that, the municipality has reduced electrical demand in this area, making it a much greener housing development. The installing contractor spoke of how easy the retrofit installation was, and how it is nice that with the 100,000-hour lamp life, there is no need for repeated maintenance. Overall, the Sacramento Municipal Utility District, who was in charge of the project, is very happy with the outcome. Alright, now let's get down to the basics, the technology behind these two types of lighting. High-pressure sodium lamps work by means of an electric arc tube filled with gas and metal salts. The gas is used to create the initial arc, and then, once the arc is started, the heat created evaporates the metal salts, forming a plasma. With use, the arc tube will suffer from blackening, where these metal salts become bound in carbon deposits on the inside of the arc tube. This blackening results in the rapid lumen depreciation shown in arc tube lamps. At the end of life, the lamp will exhibit what is known as cycling. Arc lamps can be started at relatively low voltage, but as they heat up during use, the internal gas pressure within the arc tube rises and requires a higher voltage to maintain the arc discharge. As an arc lamp gets older, the voltage necessary to maintain the arc continually increases until it exceeds the voltage that can be provided by the ballast. After ignition, the lamp will start up. Voltage will exceed the ballast capacity, and then the lamp will go out. The ballast will continue to try to restart the lamp, creating a repeating on-off cycle. The other method for an arc lamp to fail is what is called as a catastrophic failure, where the internal arc tube explodes from being weakened by many on-off cycles or excessive gas pressure within the arc tube as it heats up. The typical lifespan of a high-pressure sodium lamp is 15,000 to 20,000 hours. Also, the visual output of the lamp is a point source, meaning after looking into the light source, it leaves an after image when you look away. This is the reason for seeing a large spot in the middle of your vision after looking at this type of light. Moving on to the everlasting induction bulb, you can see right away that this technology is a completely different animal. Rings with magnetic coils create an electromagnetic field using a high frequency that is generated by an electronic ballast. This field goes around a gas-filled glass tube. A closed loop is formed by the discharge path induced by the coils, which causes the acceleration of free electrons that collide with mercury atoms and excite the electrons. As the electrons begin to reach a lower, more stable level, they give off energy in the form of invisible ultraviolet light. The UV light strikes the phosphors lining the tube, creating a reaction which changes the UV light to a harmless white visible light. The fields generated during this process are maximized by the lamp's unique shape. This all happens in a split second and is difficult to catch with the naked eye. Because of the bulb's shape, the larger source of light for induction is less intense to look at than that of the point source output of a metal halide or high-pressure sodium. You can look at an induction light source and not suffer the afterimage effect, thus making it the optimal light solution for any application. Also, with no electrode to fail, like typical fluorescent bulbs, this type of technology can last 100,000 hours, which is 5 to 10 times longer than a typical high-pressure sodium bulb.